Today we're going to be talking about the decomposition of metal carbonates. First, like we always do, let's break down our components and see what they mean. Let's look for things we recognize. First, we see metal and metal. An example like your magnesium plus your carbonate. You notice our carbonate, which is our CO3. And then we have heat, which is applied, which is going to be your little triangle over the arrow and break into metal, just like up here. Oxide plus CO2. And what's a metal oxide? Just like we've talked about before, it's going to be your metal, like up here, your magnesium and oxygen. And then you take the charges of both of these. They're both +2. This one's a +2, this one's -2, and so you just need one of each. And CO2 is already written out, carbon dioxide. Now let's look at a couple examples of how this works. So if this is what we're given, first what we have to do is identify what we see so we can know how to break it down. So we look at this and we see calcium carbonate. What's calcium? It's a metal, so we have our metal and our carbonate. So this is what we're doing. We're doing our metal carbonate, and then you will apply heat. And what does that break into? A metal oxide and CO2. We can just write over here, leave some room, and write plus CO2. We can do that. And what does a metal oxide start with? A metal. So we take our metal from our original problem, our calcium. We can put the calcium, and then an oxide. What does that mean? Remember, it's just an oxygen. So we can add our oxygen here. And then we can do our charges to see how many of each we need. Oxygen is a -2. And what's calcium? Calcium is also a -2. JK, calcium's a +2. So there's just one of each. And so we're done here. Now we can go back and look and make sure everything's balanced. Over here we have one calcium, 1 carbon, 3 oxygen, 1 oxygen here, 2 here, and 1 plus 2 is 3, so 3 and 3. And so we're good. We're all done. Okay, let's look at this next example. This one's a little more complicated just because aluminum and carbonate have different charges. So when you do that one, it's not just an even 1-to-1 ratio. There's 2 aluminums and 3 carbonates. And so first thing we always do is we identify our parts. We see aluminum, which is a metal, and then we see our carbonate. And so what do? We apply heat and we break it down into our metal oxide plus CO2. Well, what is our metal oxide? Well, obviously it'll start with aluminum, so we'll have our Al, and then we'll have our O. But now we have to look at our charges. Aluminum has a charge of +3. Oxygen has a charge of -2. So there's going to be 2 aluminums, 3 oxygens. So now when we go back and balance, we'll have 2 aluminums, 3 carbons, 1 carbon, 9 oxygen, 5 oxygen. So that's not going to work. So now we have to go back and balance. I'm going to make the fences chart just so we can go back and look at that and how that works. We're going to have our aluminum, our carbon, and our oxygen. And like we said, there's 2 of these, 2 of these, 3 of these, 1 of these, 9 of these, 5 of these. What's the first easy step we can do? Well, we see there's 3 carbons and 1 carbon, so we can just add a 3 in front of that, and that'll multiply this by our 3, and then it'll make 6 oxygen, because not only does this go out to this 3, it also goes out to this. Now there's 6 of them. So now when we add, we have 3 oxygen and 6 oxygen, so now that's 9, and now everything's balanced.